Good morning, everybody. Welcome to today's hands-on live lab workshop. Today is Thursday, September 18th. My name is Brandon Swagman. I appreciate you joining and spending the time to us today. As always, with this live lab workshop, what we invite you to do is launch the lab, go along with the content creator. Please, any questions you may have, please ask them in the WebEx chat, and I will do my best to relay them over to Chance Cornell. So with that, welcome, Chance, to today's episode. Do you mind introducing yourself?
Yeah. All right. Thank you, Brandon. And thanks again to everyone for joining us on the Crafting Your First AI Agent Live Lab event. A little bit about myself. My name is Chance Cornell, and I've been at Worldwide Technology for a little over 4 years now. I started out as an intern, then came on full-time working with the security team, where I worked with a wide range of security products from EDR, XDR, and identity access management, and a few other things. And then about a year ago, I got the opportunity to move over to our AI Proving Ground team, where I'm now tasked with creating labs and learning paths around some of the AI topics and products that we are experimenting with in our Proving Ground. So with that, one of those topics is going to be AI agents. I want to give a little bit of background on some AI agents, but before I do that, I want to take care of our last administrative task. As Brandon said, we encourage everyone to launch the lab and follow along with us. It makes it a little more interactive from your end. So in case anyone is unaware of how you launch the lab, from this main platform page, I'm assuming you're going to be already logged in if you have joined this event, but if you're not, you're going to want to log in with the credentials that you used to join this event. And then you're going to go up here to My Account in the top right, and then navigate to My Events in this dropdown. And then from there, everyone's My Events page is going to look a little bit different, but you should all see the hands-on lab workshop. Go ahead and click on that event. And then you're going to want to click on Resources up here towards the top. And right here will be the lab that we're going to be walking through today, which is the Crafting Your First AI Agent Lab. So once you click on that, your screen is going to look a little bit different than mine because I've already preemptively launched the lab, but you will see a Launch Lab button here. Just click on Launch Lab, and it should open the lab gateway for you. So while everybody's taking care of that, a little bit of background for AI agents for anyone that may be new to the topic or is just starting their learning journey. Essentially, an AI agent is an autonomous software, usually powered by an LLM, that has the ability to reason, make decisions, and take actions to work towards a goal that it has, right? And what's really special about agents is going to be that take actions part. AI agents are able to use tools to interact with the world around them. And these tools can be things like an API call. It can be things like reading and writing to files. Maybe it's executing code or even writing code, right? Things of that nature. And using those tools, it's also able to gather real-time information about the environment that it's sitting in. So if its goal is working towards like booking a flight for someone, right? And it starts making API calls, seeing what flights are available, and a flight suddenly gets sold out, it will be able to see that in real time and adjust its course to get to its end goal. And there are a lot of different flavors of AI agents. You have things like single agent architecture, multi-agent architecture, where you're having multiple agents all work together to go towards a common goal. I will say nobody count how many times I say agents in this event because it might be a little embarrassing. But anyways, many different flavors. And I wanted to give that little bit of background information before we dive in the lab.
Chance, before you move on, can you scroll down on your screen to the lab diagram there? I think you reference a couple agents in your diagram. I'm a picture's worth 1,000 words kind of guy. So this one started to help kind of, here are my different agents that we're going to explore today in the lab. And you mentioned the API calls for data sources. Picture's worth 1,000 words to help on that visual side. So bravo on the imagery.
Absolutely. Last thing that we will touch on before we dive into the lab is if you're interested in learning more about AI agents, some of the fundamental knowledge, how do they work, what are they, what are these architectures, I would encourage anyone to go out and check out the AI Agents 101 from Concept to Creation. This covers all the basics, and it does so using this character that you can see here, which is a secret agent, kind of a play on the agent's word. And really, it's going to be relevant for today because the lab that we're going through today was built to solidify some of the key learning points that are covered in this learning path. So they go really hand in hand. And if you find any value in the lab, the learning path is only going to provide more value for you, and vice versa. So with that, I will pause for any more questions before we dive into the lab.
I'm going to interrupt you here a little bit here. So the lab is part of the AI Agent 101 learning path. For those familiar or those new to WWT.com. So what a learning path is it's a collection of content of both articles, videos, and the lab. Today, we're going to talk through the lab specifically, but there is supplementary articles and videos to help go along with the lab. So I'd invite you to take a look at the learning path with an enrollment as well. At the end of the learning path is a quiz. There's a short quiz. You take the quiz, you answer the questions, and you will get a badge on WWT.com. That badge can be shared to any of your social network areas. There's the badge. Thank you, Chance. Part of WWT.com is everybody that attends today has a members page, and you can begin to see who else has taken learning paths or completed learning paths to receive a badge in their profile. So I want to do a little bit of an overview on learning path. And back to Chance's question, at any time he is going through this lab, if you have either feedback, maybe inspiration for additional or future content to go down, or just clarification on lab, please reach out in the WebEx chat. So with that, I'm sorry, Chance, I will let you get back to the lab.
No worries, absolutely. And I will add, sometimes a learning path can seem a little intimidating, but this one is short but full of a ton of really good information. So I think it says it's an hour and 20 minutes. An hour of that is considered the lab, and then just 20 minutes of supplementary video. So really good stuff. I'm a little biased. I created it, but I think it's really good.
I do have one question in chat. Yes, this lab will remain open after the webinar. If you access this lab through the event, you will have it for 30 days. If you are a customer, a partner, of Worldwide Technology, you can select on the Learn From Us and Explore library, and you will see all of the labs, and you can access it that way too. So there's two different ways. One is through the event, which we've accessed it today, and the other is through the traditional WWT.com. Learn From Us at the top. Thank you. Sorry, Chance.
All right. So I'm going to go back to this lab diagram for a really quick second. Again, this lab was created to kind of drive home some of those key topics that are learned about in the learning path. And it did that by incorporating 3 different AI agent frameworks that we can see here. It's going to be LangChain, LangGraph, and CrewAI. Now I'll go into what makes each one of those special as we get to it in the modules of the lab. But I wanted to point out that those were chosen so that you can get an idea of the different ways that agents can be created. It's not a one answer or one framework is the best. There's a whole different array of ways that you can create these AI agents. So jumping into the lab environment, you should see a gateway like this. Over here on the left, you have your lab guide. And I will point out, if you're working on dual monitors or something, you can click on this button in the bottom left, and that will open up the lab guide in a separate tab for you so that you don't have to try to read this smaller text on the left. So with that in mind, the first framework that we are going to talk about is going to be LangChain. Now, LangChain is an open source framework used by developers to create AI applications. Like we said, an AI agent is. The difference is that LangChain is going to use a chain of thoughts, and hence chain from the name, right? So it's going to be really good for sequential linear workflows, where you have step 1, step 2, step 3, and the agent will move through those. But unless you have done some coding on your own in the background, the agent's never going to move from 3 back to 1, right? It's going to want to go into a chain of events. So let's go ahead and open up our agent frameworks here on the desktop.
So, hey, Chance, while you open that up, I do have a little bit of a vocabulary, and I will be the first one to know. I'm new to some of this. I've heard you use the word AI agent, and now you're using the word AI framework. Is there a difference? Are those synonymous with each other? What are those different terminologies there?
Yeah, so the difference, the way I like to think about it is an AI agent is going to be your end product, right? Whereas the framework is going to be the toolkit that you use to create that product. So essentially, you're using frameworks to create the agents. That's the best way that I have to kind of explain it.
Makes sense. Frameworks create agents. Makes sense.
Yes. And the last thing I want to mention about LangChain before we get into the Jupyter notebooks is that LangChain is very powerful because it comes with a ton of pre-built tools and applications and integrations within it. So that's why it has quite a bit of popularity behind it.
Okay.
So getting started here.
Sorry.
The lab is going to have. Oh,
sorry. I want an introduction. Sorry, I'm going to keep going to introduction. So today we are at a very fundamental level of this. Jupyter notebooks. What's a Jupyter notebook?
So I will open up one here to help describe it. Essentially, a Jupyter notebook is a digital workspace or notebook, as the name says, where you can have different cells of information. And these cells can be filled with visuals, it can be just text, it can be code. So it allows you to have all of these built together in one place, rather than, if, for instance, if you wanted to describe what each subsections of these code were doing in Python, you would normally have to create comments. And you would comment what that does. A Jupyter notebook allows you to kind of create a little more formatted way to explain or visualize the code that you have in the notebook itself. Hopefully that helps with a little explanation.
It did. I walked through the lab about a week ago as I was walking through it. And these are some of the terminologies that I came up going, okay, AI agents, AI framework, Jupyter notebooks. These are things that jumped out at me going, okay, these are new concepts. So I wanted to make sure we establish some vocabulary for everybody on the call because it'll be a little important as we go through this. So sorry to interrupt. I will go back.
No worries. Continue to interrupt me. So the first Jupyter notebook that we are going to look at is called Getting Started. And in the lab guide, what you'll see is it explains kind of how to use the Jupyter notebook. But other than that, the main bulk of what we would normally put in the lab guide is going to be in the notebook itself. So in the notebook itself, especially with this Getting Started one, this is really just to establish how do you get started with LangChain. We're not exactly building an agent here. We're instead just building a simple chatbot style application. But it's a way to, how do you slowly start to wet your feet into what LangChain has to offer? So you'll see that the Jupyter notebooks are laid out to where each code block that you see, we're kind of describing what's going on here. For example, first step is we're going to import these required libraries. These are required to create the chatbot using the LangChain functions. So I'll go ahead and hit play next to that. And that one can take a little bit. So we saw it take 1.9 seconds to finish, but you'll see a little check mark when it is done.
Okay, I'm going to pause you for 1 second here. So I'm putting my infrastructure experience. I'm a very much infrastructure background, so that's part of some of these questions. The red and green text inside of there, is that Python? Can you give us a little overview what's in there, what's happening?
Yes. So I am unsure. Someone would have to fact check me on whether LangChain has libraries in other languages, but for the purposes of this lab, we are using a Python LangChain library. So all the code that we see here in LangChain, as well as the LangGraph modules, will be in Python.
Perfect. Thank you.
So next step, we're going to import our API key. This is so that we get access to our LLM. We're going to initialize the LLM. With LangChain, you have, in this instance, because of the way that we are hosting our models, we are going to use the chat OpenAI because we're using as if it is an OpenAI key. So we're going to go ahead and run that one as well. And then we create our prompt template. This is how the LLM is going to receive our prompt that we're going to give it. And finally, we have this last section where we run this and we're able to ask it certain things. So again, it's just a simple chatbot. So we'll ask it, what is an agent? And then we will see the chatbot response. Again, we're not diving into agents just yet. This is just to get started with LangChain. If you ran this, I will say, make sure that you type either exit or quit in this top bar. If you don't, then it'll cause some issues in the later Jupyter notebooks. So now let's get into LangChain. The way we're going to do this is by building a very simple one agent that is going to use a dictionary tool. And the way it's going to work is the agent is going to prompt the user for a word that the user wants to define. The agent is going to again look at what tools it has, sees that it has a define word tool. That define word tool allows it to go and hit an API, get a response back, and provide that to the user, right? Pretty simple. And for this one, I will walk through the run all. So this is more Jupyter Notebook forward. Instead of going through each code block and hitting the play button each individually, you can just run all. That will treat it as if it's just a Python file and you're running all the code at once, in essence.
So would it be safe to say, and this is kind of as I walk through and visualize, again, we're in my infrastructure hack, a Jupyter Notebook is really a software development tool for AI function, for AI, back to stuff. It's really my development tool. I'm going to be coding.
Yes,
AI.
it is a development tool. I don't think it necessarily needs to be just for AI, but it's definitely a development tool.
Okay, thank you. I got a couple questions in chat while you go through on the run all button here. So yes, this is being recorded. It will be available on wwt.com at the event page you're on now. It will also be posted to YouTube as well. As far as their other AI learning paths, yes, there are more AI infrastructure learning paths. You would go to wwt.com, learn from us, and you can focus both on learning paths and learning series. I did post one in the chat, but there's others available as well, along with, if you're looking for something as simple as Python, there is a Python learning path in the libraries as well. Sorry, Chance? I promise I'm going to quit interrupting you.
No worries. No worries. So this Jupyter Notebook is going to have a lot of similarities to what we saw in the last one. So I'll skip over the stuff we've already seen and talk about what's different now that we are doing an actual agent. The first one is going to be this defining tools step. With LangChain, you do have predefined tools, but you can also create your own custom tools. In this one, that is what we did. We created a custom tool that goes out and hits a dictionary API, gets just the definition, because when it hits the API, it gets back the whole response, and we don't necessarily want the whole response. And then it returns that definition to the agent who is called the tool, right? Again, we do the same thing of set the API key, initialize the LLM. This is all the same. Another step that is different is now we have to actually initialize the LangChain agent. And essentially, when we're initializing the agent, we're telling it what tools it has so that it knows which ones it can use. We're going to tell it where the LLM is, because that's the brains of the operation. And then we're going to tell it what kind of agent it is. Now, the kind of agent within LangChain can get a little bit outside the scope of what this fundamentals lab was designed for, but I do describe those here in the Jupyter Notebook if you're interested in seeing what the different kinds of agents are and which one we're using. In this case, we're using the zero-shot React, which is just a React agent, which means it will reason and then act, and then reason and act, right? So it keeps that going until it gets to its end goal. So we define our agent here, and then at the very end, all we need to do is get the word, provide that to the agent, and it will get response. So here I will define the word agent, just to keep the theme going. And you will see here our agent executor chain. So we'll see that first it thought, I need to look up what the definition of the word agent is. It then looks at what tools it has, where it sees the defined word. It provides that input. Its observation is the output of that tool that it just ran. And then it thinks, I know what the final answer is, and I'll provide that to the user, right? Very, very simple agent. But again, just to get you familiar with LangChain and what you can do. So I will pause there before we move to LangGraph if there's any questions.
Nope, I'm not. I promised. I'm going to stop the interruptions. So no questions and chats to bring for you right now. But again, I want to remind the audience, as Chance walks through here and you walk through the labs yourself, if you have any questions, please post them in chat. So continue on, Chance. Thank you.
Absolutely. Or if there's anything you want me to dive a little deeper in, I don't think anybody wants me to sit here with these Jupyter notebooks and read to them what is written. So, but if you have a question on anything a little more in depth, then let us know.
Makes sense.
So LangGraph. The naming convention is not just a coincidence. LangGraph falls under the same family or ecosystem as LangChain. The big difference is, instead of using a chain in a linear fashion like LangChain does, LangGraph, you are now building a graph. And the graph kind of looks like a state machine. And if you don't know what a state machine is, it's kind of like this over here. This is a very simple example. But essentially you have nodes, and then you have conditions linking those nodes together. And depending on what conditions are met, you move from node to node in no particular order, right? And what this allows LangGraph to do is to be used for more complex use cases, or even creating like a multi-agent architecture. which is what we're going to do in our example here. So I will go ahead. I collapsed the LangChain folder on the left and opened up the LangGraph. So if you want to keep things a little easier to read, I would recommend doing the same. And I'm also going to close out of these Jupyter notebooks along the way. And you don't have to save them. The saving is just because you ran the Jupyter notebook. So with LangGraph, again, we're just trying to keep it simple, but show what the framework can do. And what the framework is really good at is having the agents make decisions, loop back. They have a shared memory because you're moving from node to node, and you're collaborating based on that shared memory. So for our example here is we're going to create a multi-agent architecture, which again is just multiple agents working together. Each one has its own role that it plays. And we're going to have them plan something for us. For instance, baking a cake is what we're going to use as the example here. So we're going to have an agent that is going to plan out how do you bake a cake. You have to go out and get the ingredients, come back, preheat the oven, combine these things together, right? And then we're going to have an estimator agent. That agent is going to take the plan that the planner agent has created and estimate how much time is required for that, right? We're then going to have an agent that decides, is that plan realistic? You know, if the planner agent says that you need to go all the way across the country to get this special ingredient, that's not quite realistic. So it will have it to where we check to make sure the plan is realistic. If not, we go back to the planner agent and we're like, hey, this is not realistic. We need to rethink this.
Hey, Chance, I'm just kind of walking, as you went through that analogy, so LangChain, would that be considered like a serial compute function where LangGraph would be more of a parallel where I'm doing multiple things at once? Is it accurate to think of it as serial versus a parallel processing?
Not necessarily, because even with LangGraph, only one agent will be working at a time versus there are multi-agent architectures. So I will say for this instance, there are multi-agent architectures where you can do things in parallel, but in this lab, we are doing things one by one.
Okay.
If that makes sense.
Yes.
But one of the draws to multi-agent architecture is that ability to perform things in parallel rather than having to wait for each task to be completed before you move forward. So that is a very good point. That's covered in the learning path that people can go check out.
Well plugged. That wasn't planned.
Any other questions, or should I continue on?
I'm going to let you. I do have a question, but I'm going to hold it here and let you continue on with LangGraph.
Okay. So very similar to LangChain. Again, this is Python. It's a Python library within the LangChain ecosystem. So we're going to call in all the libraries that we're going to need. And then this is a big difference between LangChain and LangGraph. Because we now have different nodes working together and potentially different agents working together, you need to have the agents be able to know what the previous agent has accomplished. And by the way we do that is you define a shared memory, which is called a state. So here we define all the things that we want to be in that shared memory that all the other agents can look at and ensure things are staying consistent. Again, we define our LLM. This stays the same across both frameworks. And then here we are going to start to define our AI agents. These are our nodes. And again, I explain here, you have your planner, estimator, realism checker, simplifier, as well as the finalizing agent. So this is very specific to the LangGraph framework. This is Python code. I'm not sure we really want to dive deep into what's going on here, but essentially this is how you're describing or defining the AI agents themselves. Each one's going to have a goal. It's going to have a prompt. It's going to invoke the LLM with that prompt, and then it'll work through whatever its goal is, as well as you're passing in the state, which is the memory. And then we define our finish node, and this node pretty much just puts everything that is gathered from all the other nodes in the shared state and displays that in a way that's easy for the user to read. Then we have to build our graph. And then within building graph, you have to add your nodes. You add your edges, which is how can you move from one node to the other? Where are you going? You have a conditional edges. This is, hey, if this condition isn't met, you repeat what you've done or move back to this other node, right? So all of this code right here is just building a state machine like we see on the left. Not exactly like this one, but its own state machine. And then finally, you run the workflow. So I am again going to hit run all at the top. And this could take a second. Oh, it's ready. How to bake a cake. And then that is done. So we'll see here. And the Jupyter Notebook does its best to try to format the output to where you can read it, but still has some quirks. But we can see here that the finalizer has given its output. But if I scroll up to the very top of our output, we can see that the planner is thinking. This is what its thought process is and its output. And then we have our realism checker. Oh, I think I missed our estimator is thinking based on the plan that the planner has created. The realism checker runs, and then finally it gives that final output. So again, the whole point of this one was to get you a little more familiar with the LangGraph framework, creating that state machine or graph. Hopefully you can see how it can be used for a little more complex use cases. But I will say that you can probably tell as well, if you don't have a coding background, the more complex the use case, the more complex the code. So it can start to get a little bit more intimidating. And that was some feedback I've heard from some people that have done the lab that don't have a coding background. But any questions?
Yeah, I do have a question here in chat. So you finish that before we move on to the third AI framework. How's the lab built? This is a little bit from, we'll call it under the covers. How is the lab built? What is this running on? Is this something, if someone was building something similar at home, what would they need? And I guess the million-dollar question are you using one of those coveted GPUs that we hear and almost synonymous with with everything AI? So what does this look like on the back end?
Yeah, so we have set up for the AI Proving Ground a cluster of GPUs that we're able to tap into for these labs. So if you were to want to build this at home, you would probably need to have some sort of API key and tokens with OpenAI or a machine that has GPU that you can tap into. For this lab, the magic's really happening in that we have a cluster of GPUs that are running LLMs that I'm able to utilize to act as the brains for these agents.
Thank you. So I'm going to turn that question, Chance, and I'm going to point it to the audience. So is there a particular scenario you're using these AI frameworks in your environment, in your work or investigation today? And I ask that question I'm trying to give Chance some inspiration on where to take his future content as he builds onto this. So are you using one of these AI frameworks today in your world? What is that scenario? And is there some context you could provide, and maybe Chance could use that as inspiration for content in the future? So thank you. Those are the two questions there. Chance, I'll let you jump over to the third framework.
All right. Our last and final framework is going to be CrewAI. CrewAI, when I started down this AI agents journey, is actually the first one that I ended up on. And that's because I started seeing a lot of people building out like personal projects utilizing CrewAI. And when I dove into it, and then I later dove into LangChain and LangGraph, I felt I needed to include it in the lab because it is so much more unique than, not more unique, but it is unique compared to LangChain and LangGraph. And the reason for that is a couple different things. First and foremost, when you install LangChain and LangGraph, you run the install and that is it. From there, you have to go out and find what functions or tools that you want to call in order to build out your agents with that, right? CrewAI, when you run the install, it downloads all of the files that you need to run a crew, which is your agents. But above that, it comes pre-built with agents. So immediately after install, you can go and run the crew, and it'll run these agents so you can see how it functions. The other thing is, and you'll see it as we start to go through this module, is that it's less coding forward, in my opinion, and more of how well can you articulate and describe what you want these agents or tasks to be. So you're filling out these YAML files. So you do need to know a little bit of YAML, but not a ton because they already create the files for you. And you are essentially just, hey, I want this agent. What is its goal? What is this agent here to accomplish? What is their role? Are they part of the marketing department or are they an engineer? What's their backstory? Are they an engineer that only has, a couple months of experience, or are they a seasoned engineer with 10 to 15 years, right? So all of this is things that you have to kind of write out a story in order to get CrewAI to function. And the better the story, the more consistent and better outputs you begin to get from these agents, right? So I will go ahead and open up Crew. Now you will also notice it's a lot more files. So we don't have our Jupyter notebook for this one. We're going to be copying and pasting from the lab guide that you have on the left. But to get started, you're going to open up the CrewAI folder, and then you're going to open up source. And in here, in this source folder, is all the files that we are going to edit. First, we're going to start under the config file. And I'm going to open up the agents.yaml. And I'm going to close this and not save it. So in the lab guide, if you're going through it on your own, you will notice that I have gone through and added each line of code that you would put in the files. But also at the end, I will normally say something like, after you define everything, your file should look like this. So we're going to, for ease of copying and pasting it all, we're going to just jump straight to that and paste that into our files. And then I'll go ahead and explain what we got going here. So in the agents.yaml file, this is where you are defining what agents you have. So you start by giving them a name. In this case, we have a researcher and a writer, right? Then you have to define the role. We are going to say that the researcher is a parentheses topic, which is to say whatever topic we give it, they're a senior researcher for that topic. Same goes for the writer. They're going to be a reporting analyst for that topic. Then we give the goal. For the researcher, we're going to say gather accurate and up-to-date information on whatever that topic is. Similar thing goes for the writer. And finally, we give them a backstory for it. So in this instance, we're saying you're an expert researcher skilled at finding reliable sources and summarizing key points clearly. And then we will do something similar for the writer. So this is where you're starting to tell that story. You're starting to build upon things to clearly define to the LM what is this agent here to do. So I'll go ahead and save that file. Make sure you save. If you don't, you'll encounter issues when we go to run these. And then we're going to go to tasks. The task.yaml file is where you are going to define what exactly the agents are going to do. And I do note some of the interesting things about CrewAI in the lab guide if you want to read through that. Things like there's different methods that the crew can go through tasks, whether it's sequential or hierarchical and all that. But for the purposes of this event, we'll skip over that. And then we'll copy again. I say that this is your complete task, so we will go ahead and copy that one in. I do also want to note, this is more Lab Gateway in general. If you're ever having issues with the copy and paste, sometimes if you just come over here to the lab guide, copy this, and then assume that where your cursor is here is where you want to paste that, it will paste what you previously had copied. So always make sure that you click back into this window. That's just a general WWT ATC Labs copy and paste hint.
Brilliant minds think alike. I was just getting ready to point that out, how you're selecting the copy button with the mouse and not doing a Control-C, Control-V. So thank you for pointing that out.
It can be a little bit particular with how it wants you to do it. But so the task.yaml, this is where we're defining what exactly these agents are going to do. So in this case, we're going to have two tasks. One is for the researcher and one is for the writer. For the researcher, we're going to give it a description of the topic that we had previously put is going to be the future of AI in education. And we want them to provide 6 key insights. And then we give them an expected output, a list of 6 summarized bullet points with reliable and current information. So here you're really, the more you're able to tell the agent what exactly it's supposed to be doing and what the output is going to be, the more reliable the agent is going to perform this task. And we do something very similar for the write the article task and the writer. So again, you're going to want to save that file. And we're next going to open up crew.py. Now this is again Python. This is the only coding part that we have within CrewAI. And for this, what we're going to be doing is defining our agents and defining our tasks. But for the crew in Python, right? So we already defined them on our own. Now we're adding those as functions. So I'll go ahead and copy this. and paste that here. And the one thing you have to be careful with, I tried to make it as consistent as possible when building the lab, but from deployment to deployment, it seems to be different. You want to make sure that your tabbing is correct here. Sometimes when you click here, it'll have correct tabbing already. And then when you copy and paste, it's perfect. Other times you have to correct the tab. So for instance, when I pasted, it looked like this. So I just need to make sure I tab that out to get rid of the error. And then after those agents are defined, we will go ahead and define the tasks. And again, I'll paste those in here. And then save the file. And then down here remains unchanged. But if you were to want to change the way your agents function, for example, right now we're doing sequential, which, as you mentioned, Brandon, is serial. You're going one by one. You can change it to do in parallel, but for this lab, we keep it at sequential. And then I provide what the whole file should look like in case you have any errors that you do have. And we are ready to run our crew. So I'll go ahead and click on Run Agents. And to run our crew, it's a very simple command. We're just going to do CrewAI run. And I will say that this script that you're clicking on here, the Run Agents, is just opening up a command prompt in the correct directory. If you don't do that, then it won't know that there's a crew there that it can run. So I'll go ahead and run that. And this is a perfect time for any questions because this can sometimes take a while for the agents to wake up from their nap.
Perfect. I'm going to let you take a little bit of break here and answer some questions in chat. So there was a little bit of interest in AI when it comes to network automation. I posted a link to WWT Agentic Network Assistant. That is a lab that is being created. It's outside the scope of today's call. Today it's read only, but it does have potential and it will be going into a direction to be able to create configurations as well as investigate network configurations and a small amount of troubleshooting. So if you're interested in network automation in relation to AI, check out this lab. The catch is you must be a customer of WWT to launch that particular lab, but that lab is taking a life of its own. There was another comment about copy and paste. So sometimes if you're on a corporate laptop, we have seen corporate security devices impact the copy and paste function between if there's a data loss prevention agent or tool running in your enterprise. We have seen them impact copy and paste functions when it comes to usability of the ATC gateway. With that, I'm going to turn it back to you because I see output scrolling by on your screen, Chance.
Yeah, perfect timing. So I'll go ahead and scroll back up here and explain what we have going on. So we'll see that our crew starts to execute. And the first agent is going to be our senior researcher. This just popped in my mind because I built another lab around CrewAI. But if you go and experiment with CrewAI on your own, from my experience, whatever agent you have first in this file is the agent that's going to run first. So keep that in mind if you do any experimentation on your own. But we see that our senior researcher kicks off and it knows that it's researching the topic of the future of AI in education. And it wants to provide 6 key insights. So it goes off, does its thing, gets the answer, and provides its 6 key points. It then goes, am I done? Yes, that was the only task I had. I've completed the task because I got all the 6 key points that it asked for, and I can go back and take my nap again. And then we see that it goes, all right, the researcher has run. Are there any other agents? In this case, there is an agent. It's our reporting analyst. So that agent now starts. It's going to go and look at the information that the researcher has given it. And it's going to say, okay, this can be formatted a little bit better to be for an article, right? So it's going to format that information into something that is a little more easy to digest. And then it gives that final output for users. So again, very simple use case for CrewAI. Very simple use case for all of them. I do want to mention, if you ever go or are curious and go and use these frameworks, just know that this was designed to teach the basics. These frameworks can get much more complex. You can do a lot more with them, and they can be very powerful for building AI agents. But that is pretty much it for the lab. Any other questions?
I do. I have a couple questions rolling in. First, can you go back to the tab that had the diagram on the initial lab launch page?
Yes, I can. I believe that's here.
Okay, so I have here my 3 different frameworks: LangChain, CrewAI, and LangGraph. And I believe you may have colored this in the lab guide, but I don't think we spoke about it today. How do I know which one of these is right for me to use? What would be my analysis to say I should go CrewAI or I should start with LangChain? What did that decision tree look like for you?
So when I was looking at it, it really, now it can be a little bit of legwork because there are a lot of frameworks out there, even way more than even just these 3. But it's going to come down to what is your use case. If you're just looking for simple agents, then LangChain can be really powerful, right? Especially if you are just looking for something linear. Hey, I want to give the agent this task. It moves through this workflow, and at the end, it has an output for me. And nothing needs to be real-time data changes or anything like that, right? If you want something more complex, then you have to look towards frameworks like LangGraph or CrewAI. And from there, it's kind of depend on your background, I feel like. I think you can accomplish relatively the same complexity with both CrewAI and LangGraph. But like I said, LangGraph, if you have a coding background, you're going to want to be coding with LangGraph, with Python. That's probably what you're going to prefer. If you don't have a coding background, then CrewAI can be a little bit more friendly for you to go and try to use. So it's going to just depend on what use case you have.
Makes sense.
And I will say, I don't know if I mentioned it. You might be wondering why I chose these frameworks. When I went out there and started to look for what I wanted to showcase in this lab, these were just some of the ones that came up consistently as I was looking at different documentation or projects that people were building. These were the ones that, to me, I felt like stuck out the most.
Okay. A question that came in chat, and this was a little bit kind of switching topics. I'm going to throw my ADHD brain of random topics at you now, so I apologize. Could somebody use a consumer, I'm going to call it a consumer grade GPU, maybe one they have at home, to build something similar? Or does this need the larger enterprise level GPUs?
So it does not need the larger enterprise GPUs. You can actually, on consumer grade, I've done it on my own personal computer. You can run things like Ollama, which will allow you to run an LLM on your own PC. And then LangChain, now you have to do a little bit of legwork because it was really designed with OpenAI in mind, but you can then run Ollama in frameworks like LangChain or CrewAI. So you can do it on your personal consumer grade GPU. I will say though, the thing that can be impacted is performance. Like CrewAI may take a long time to run, or LangChain can take a long time to run. And also, as I experimented with these different frameworks, something I found interesting was just how impactful the different models that you use can change how well the agent does, right? So there were models that CrewAI said was supported, but I could not get the agents to run successfully. They would error out every time.
Makes sense. So I'm going to turn that question a little bit different here, because as everybody knows, we start creating content for WWT.com. It really has a life of its own, and you're trying to figure out, where do I take this content from here? So my question, I kind of point it back towards the attendees, is what are you trying to do? Is that potential inspiration for Chance here to make future content on this subject matter? So I'd love to understand more context of what you're trying to do at home.
Absolutely.
I do have a question here. I'm going to just go word for word because I'm not sure I totally understand, or I'm probably not even qualified to ask this question, but I'll try anyway. Model training, does it work like TensorFlow? I'm not sure of the context of that question, but are you familiar with TensorFlow?
I don't know if I'm familiar with either of those enough to speak on it.
Okay. Makes sense.
This event. I haven't done much model training myself, and I have not worked much with TensorFlow. So
love it. Perfect. I'd appreciate some more context behind that question. Again, Chance, here's some inspiration where you can take this content into the future.
Absolutely.
I'm going to ask you here, Chance, what was your surprise? What was your biggest lessons learned, your unexpected aha, whether it's technical or not, as you started to go down this path? Something you realized now that you didn't think you'd know when you started on this journey with agents?
Yeah, I kind of threw it in throughout the event, but first and foremost was just how many different frameworks there are to create AI agents. Like I said, they're toolkits. So there are a ton of different ways that you can create these AI agents. You know, Copilot has ways to create their own agents. LangChain, CrewAI, lots of different. From there also was what I was talking about where, you know, not every framework is going to respond to the same AI models the same. CrewAI loves certain models, would not run on other models. LangGraph would run on certain models, and the output on others was not as good. LangChain would run on anything from my experience, right? So it's just having to experiment with how can I get these agents to perform the best.
Okay. Where can I go to see all the different frameworks? You mentioned these three, but you mentioned several others. Where would somebody new to this area go to see just, you know, is this a list of 20? Is this a list of 1,000? Where do I get my frameworks?
I don't know. So when I was going out and trying to find them, I don't know if there was one particular source of truth, but I would recommend, you know, Google is your best friend. Try to look up AI agent frameworks. What are the most popular AI agent frameworks? And don't just stop at the first response that you get. Dig deeper and see what names are repeating in these lists. That was kind of the method that I took.
Okay. So we do have a little bit of suggestions for some advanced sessions here, creating dynamic agents and looking for anomalies. So I appreciate that suggestions on where do you go. Where do you see this content going today, Chance? I know you haven't read the chat log here to see everybody's dialogue coming in, but where do you see this particular lab and learning path going into the future?
You know, that is so hard to answer. And I will say that because if you were in the AI space in 2024, everything was about LLMs. If you're in the AI space in 2025, everything has shifted to agents, it feels like. So I don't know if the content goes to here's more complex use cases for what agents can do, or in 2026, are we going to never talk about agents again and it's something completely new? So I honestly have no clue where it's going to go.
That's a really good point. I didn't even consider the area that is AI continuing to evolve rapidly. This is an interesting question that came in here is, are there any anti-patterns that you'd notice or ran into early that you'd suggest avoiding? So I guess that question is, what broke on you? What would you avoid? Whether that's a pattern of things you've done repeatedly, is what broke? Where would you recommend avoiding?
So one thing that sticks out, and this was hard to do in the lab, and you may not even run into it in your own use cases. I was trying to showcase LangChain and LangGraph specifically in their own modules, right? But like I said, they come from the same ecosystem. So oftentimes the functions you're using for LangChain will be used in LangGraph and vice versa. So don't be afraid to be like, well, I want to build a LangChain agent. If there's a function in LangGraph, there's a pretty good chance that it works for LangChain as well. So don't try to be very separated. That was what I ran into a lot of troubles with, was trying to separate the two as if they're two separate entities. From there, with CrewAI, I've done some more complex use cases there. You need to be very careful with how you are writing those YAML files. When I would write something, it makes sense to me, but then the agent would give a completely separate output from what I was expecting. And that's because the way I'm interpreting it is not the way it was interpreting it. So you have to kind of refine what you're saying to get to where the agent is functioning like you want. And don't be afraid to, all right, the way I wrote that this sentence or this paragraph is not working, let's scratch it and start fresh. Maybe I need to look at it from a different angle.
Makes sense. can you do me a favor and go to the last tab in your browser there?
Yes, I can.
Thank you, sir. So one thing I want to do is take a few minutes is, again, any inspiration you can give Chance or direction you would like to see this content, please put this into the WebEx chat. I will copy this and give this to Chance right after the session today and let him figure out, as he kind of alluded to, that ever-evolving future of AI and where he can go and where you'd like to see this content goes. But with that, so today, is today's topic of AI agents. Next, I believe it's October 9th on your screen there. I was reading, but I couldn't read for a second. So we'll be joined by Shohab Shahpui to talk about mastering threat detection. So everybody's aware that October is Cybersecurity Awareness Month. So we are going to kick off October 6th Cybersecurity Month with our hands-on live lab being Cybersecurity Month. So this will be going into a security operations playbook using some different components like CrowdStrike. That event I will post in the chat is available on WWT.com today, so you can register for that, and it will be going out in email as well. So this is our upcoming event in 2 weeks. Chance, thank you very much for your time. Number 3, so everybody, this is Chance's 3rd time coming on our Hands-On Live Lab series, so thank you. We greatly appreciate that. Some of Chance's previous visits are recorded on WWT.com and YouTube as well. Everybody will get a survey, so please take a moment to fill out your survey. What did you like about today's sessions? What kind of inspiration could you give going into the future? Or is there generally things we can improve? I'd greatly appreciate you filling out the survey. And of course, last but not least, I appreciate everybody's time in attending today. I appreciate all the dialogue and questions in the chat. With that, have a great day, everybody. Thank you very much for attending.